So solving the graph of the polynomial function tells us we have roots at -2, 3, and 5. So I'm just going to sketch a quick graph here. So -2, 3, and 5. Okay, and then it has a point at 1/16 up, maybe somewhere around here. Okay, so we can kind of see if this polynomial is positive or negative by just kind of trying to draw. So if I try to draw that, that's not going to work. Okay, it's going to have to cross the x-axis here, and I need another root. So to be able to reach that point. So the only way I can draw it, it looks like it's got to be from down here. It's probably going to come up here like this and like that. So it looks like the way it's from the information given that the a must be positive. Okay, but we don't really even need to know that. We just need to figure out what this function looks like. And to do that, we want to set it up, and we want to set it up in factored form. So we have x plus 2, x minus 3, and we also have x minus 5. Okay, now one thing that we really have to make sure that we account for is that you always consider the a. And when we solve for that a, it should end up being positive, and we're probably going to have some compression or expansion involved in here. And to solve for that a, we just plug in our x equals 1. So we end up with y equals 16, a 1 plus 2, 1 minus 3, 1 minus 5, and then we can solve for a. So we end up with 3 times -2 times -4. So that's going to be positive 8 times 3 is going to be 24a. Okay, so when we solve for a, we end up with 16/24, which simplifies to 2/3. So the equation then that we end up with for this polynomial, and it works out that the a is positive, which is what we would expect. And the factors are x plus 2, x minus 3, x minus 5. Okay, so there's our solution for that problem. So here we have a parabola. Its axis of symmetry is at x equals 3, and we have a 0 at -5. Okay, so let's just quickly sketch this graph. Okay, so we have axis of symmetry at 3. So that's the middle line is going to be at 3. And we have a 0 at -5. And what we're being asked for is the coordinates of the other 0. Okay, so we know that it's symmetrical about the middle there. And we know that that's distance of 8. So we can just use that same distance here of 8 and find that coordinate here. Ends up being, looks like it's going to be 11. Okay, so one way that we can just count this and find distance, again, we can subtract to find the distance, and then we can add on from position to position. So it's really important that you keep in count whether you're talking about a length, which I have in red, or the positions I have in black, right? So that's a position of -5, positive 3, positive 11. We can solve this another way by generalizing this root as x, and we know that if we add the outer points and divide by 2, we get the middle. Okay, so we take the average of the outside coordinates, we get the middle position. So we have x plus -5 divided by 2 is going to give us the middle position of 3. So when we work this out, we're going to end up with x plus -5 is equal to 6. add 5 to both sides, we get x equals 11 in that way as well. So that's another alternative way we can solve for this. In fact, the nice thing about this is this is just using positioning. So it doesn't use a length of 8. So we're always talking about a coordinate position when we do this, when we use this method here. Okay, so when we have algebra pieces in there, it's easier to keep track of, and we're not going to get mixed up by length versus coordinates.